Hi, I'm Corinne. I'm going to present the work I'm doing with Kristen Kedar and Alastair Donaldson on compiler testing and fuzzing. Fuzzing is an efficient and successful method for testing compilers, in which we aim to expose miscompilations via differential testing. A test case is a program which we can compile with a compiler A and get a binary, and then run this binary and get a result, A. We can repeat the same process with another compiler B, get a binary, execute it and get a result B, which is supposed to be the same. However, if result A is not equal to result B, then we have a miscompilation, which can affect any program that compiles with this compiler. The main challenge when testing a compiler is generating programs that are free from undefined behaviors. Undefined behaviors can be, for example, a division in zero or signed integer overflow. Non-UB-free programs have unpredictable program results. They don't describe a problem that is a bug and cannot be considered as a valid bug. One of the successful and common tools for compiler fuzzing is Sysmit, that found and reported many bugs in mature compilers. It has during and post-generation solutions to assure it generates UB-free programs. For arithmetic operators, it avoids undefined behaviors by using safe math wrappers that looks like this. So we have an unsafe check, and if A and B on operator circle is triggering an undefined behavior, we return A. Otherwise, we return the result of A circle B. For instance, if we look at the example on the right, we have in the for loop a plus and division operators. And to assure we don't trigger any undefined behavior while using this program for testing a compiler, we are going to replace it with safe add and safe div. For division, it looks something like this. So if B is equal to 0, then we just return A to avoid triggering undefined behaviors. Otherwise, we return a result of A divided by B. During time, compilers became immune to these fuzzers, and in the next slide, we present our observation and hypotheses that lead to new bug reports. This is a code fragment of a real test case from Sysmit, where we can see everywhere the safe math wrappers, also for multiplication, shift, and modulo, besides add and division. An interesting observation is that these checks appear several times in instructions, and we don't see any of these operators as is outside of the ternary operator. This can be a problem because some of the code optimizations in the compiler can be inapplicable if enclosed in these checks. We hypothesize that these wrappers limit the form of programs we can generate because these are actually everywhere. If we look at the example from before, safe div is required when we pass through 0. However, safe add is not required. At the beginning, we have s equal to 5, and then we add 8, 7, and so on. So actually, we don't need the safe div. And by using this idea, we managed to find new bug in GCC. And the idea is to be less conservative when generating UB-free programs to test compiler. We have the generator, which is in our case Sysmit. It generates a test case. We then use our dynamic analysis to identify and eliminate this redundant check. The dynamic analysis will output a relaxed test case, which contains only when it's needed these checks. For example, if we look at the example from before, the original test case will include safe add and safe div, but the relaxed test case will leave the plus operator as is. We did our evaluation with 100,000 test cases. We found 2 new bugs in GCC 10 with P2 normal importance in the tree optimization code. These bugs were fixed promptly and can only be discovered by a tool, Sysmit Edge. We also reported several more bugs after writing this paper using Sysmit Edge. Also, the line coverage was increased in 4,000 lines, as you can see on the graph on the left. The green line represents the line coverage achieved by Sysmit, and the light blue line represents ours. In the future, we are going to use our tool to try to find new bugs, not only in GCC, but also in other compilers, like LLVM or Microsoft Visual Studio. In the flow of our approach, we plan to extend the possible modification we allow in the relaxed test case, and also to explore the idea of relaxing the restriction during the test case generation, that is, in the generator itself. The restrictions that are related to generating UB-free programs can be, for example, forcing initialization of variables when declared, or controlling the index's value when accessing an array. Then, after, we use sanitizers and static analyzers to detect and discard those test cases with undefined behaviors. If we don't have undefined behaviors in a test case, we can just use it as a regular test case. That's all. Any questions?